Find the volume of a solid of revolution formed by revolving the region bounded above by f of x equals 4 minus x, and below by the x-axis over the interval 0 to 4 around the line y equals -2. Okay, so we've already got some images here from the publisher. The graphs are already made for us, so we have f of x equals 4 minus x and y equals -2 as our axis of rotation. And the region is bounded below by the x-axis. All right, so y equals 0. All right, and then we have another image here of the rotated value in 3D. We never really need to see that. The integral itself will take care of all the parts in the third dimension for us. We just need to see it in 2 dimensions so that we can set it up properly. Okay, now, since that's my axis of rotation, here's my approximating rectangle. And the thing about this being my axis of rotation here is that if my axis of rotation were the x-axis, I wouldn't have a gap between the region that I'm rotating and the axis of rotation, and I could just use the disk method itself. But as it is, it will use the washer method because the rectangle or the region is not fully connected to the axis of rotation. Okay, so let's see what happens here. So to get started, to find this volume, we effectively just need to decide on what is our outer radius and our inner radius. Okay, so the outer radius is going to be the point on the rectangle that is always furthest away from the axis of rotation. So that's this distance right here. And then the inner radius is going to be the point on the rectangle that is always closest to the axis of rotation. All right, so in this case, the outer radius, it looks like it is 4 minus x. But the problem is, it's not really. It is further than that, right? It's always a constant distance of 2 away, and then plus this 4 minus x. So in order to get the full distance, we need to get the vertical distance between f of x and the axis. So normally we don't consider this if the axis of rotation is 0. But if the axis of rotation is non-zero, we get the outer radius by computing the total distance between these two. So the total distance is going to be 4 minus x minus -2. And that's going to give me the total distance from this point, which would be any point on this curve, down to the axis of rotation, which looks like it would be 4 minus x plus 2, or 6 minus x. The inner radius. All right, so the inner radius here, again, we can think of it in terms of a vertical distance. So the function is always y equals 0. So it starts at 0, but then there's always a distance of -2, so minus -2 from there. So the inner radius from the bottom of this rectangle to the axis of rotation is always a constant of 2 units. All right, so we need to take care of that sort of thing first. Then we can start getting into working out the formula. So, of course, the volume says this is pi times the integral from a to b. Well, a is going to be 0, and then we're going to go up to where they intersect again here at 4. So 0 to 4. Then it's the outer radius squared, so 6 minus x squared, minus the inner radius squared, so 2 squared, dx. All right, and that we can go ahead and put into fn int. And let's see what we get here. So math 9, so 0 to 4. And I'm going to put in parentheses here. The parentheses get a little bit weird when you're using fnint, because the outermost parentheses, you can't put anything on the outside of those. So you just have to always insert additional parentheses on the inside. All right, that looks good, and that computes there, and let's turn that into a fraction. So it looks like 160 pi, so we still have this multiplier of pi here, over 3. And I should always indicate that that came from fnint. So there's the value of that. Okay, now I want to do a slight variation on this problem where the axis of rotation is actually oriented above the region. All right, so I'm going to have the same basic region. Okay, and let's see. 1, 2, 3, 4. All right, so here's this line, and then the axis itself is a boundary. So y equals 0, and then I will put another boundary here. All right, but this time I'm going to rotate around, say, like y equals 6. All right, so I want you to see what happens here, because it can get a little bit confusing when you're thinking in terms of like positive and negative here. All right, so I'm going to rotate this region around y equals 6. Okay, so here's my approximating rectangle. And when I set this up, clearly that's still x equals 4 as that. So my volume would be pi times the integral from 0 to 4. And I need to do my outer radius squared minus the inner radius squared dx. Okay, so determining what that outer and inner radius are is really the key. Now, the thing is, the bottom here is the most negative, but it's actually the furthest point away from the axis. So when I calculate this, that's going to be my outer radius. And I'm going to calculate it using a vertical distance, because, and I'm saying that this is the outer radius because it's the furthest radius from the axis of rotation. So to calculate this vertical distance, I'm going to take where this is located, which is at 0, and then minus, well, actually, I need to make sure it stays positive when I compute. So, and it will when I square, but I need to be careful here. So it would be 6 minus 0 to get that vertical distance and make sure the vertical distance is positive. All right, so my outer radius here is just simply 6 squared, so that's going to result in 36. Now my inner radius is this distance here. And again, it's confusing because it looks like this should be the outer because it's the most positive with respect to, the region drawn. But with respect to the axis I'm rotating around, it's the closest point to the axis. So that inner radius, let's see here. To get that, I would take 6, which is the highest point here, minus the point located along this line. So minus 4 minus x. All right, so then that would give me 6 minus 4 plus x, which is 2 plus x. Okay, and that can be confounding, but that's the way we would solve this particular problem. All right, and let's finish it off here. Just putting it into the calculator. So we'll integrate from 0 up to 4. And then it's 36 minus, parentheses, 2 plus x, quantity squared, dx. Whoops, don't know why I hit graph. Force of habit, probably. All right, now let's make that a fraction. So we get 224 pi over 3. All right, there we have it.